Hello my dear friends, welcome to the last episode of 10 channel lighting system project. This is Electronic Wizard at your service. Here, this is me. I'm gonna explain all the details about this project in this video. By the way, there is a link to the files necessary to build this project in the description of this video. By clicking the link, you will download a compressed file containing two subfolders like this. The PCB subfolder and STM32Cube IDE codes. The second one, this one, contains the project cube IDE project of this project. Anyway, and the first one is the PCB containing Altium Designer projects for three PCBs. Three schematics and three PCBs. I'm gonna explain all the details here. Let's not waste time and dive into the details. I'm gonna start with this capacitor bank here. There is a capacitor bank in this project for smoothing the output voltage. You know, there is a input power line. We will rectify the power line and then pass it through this capacitor bank to smooth the voltage to reduce flicker at the output channels. You know, we have 10 light channels at the output of this project. So we use these 16 capacitors to smooth the voltage and reduce the flicker. You can use more than 16 or less than 16 according to your requirements and your interests. Anyway, there is no specific thing about this PCB here, and understanding this part is not a big deal. I'm gonna skip the PCB file and I'll look at the schematic of that PCB of the capacitor bank. Here there are a bunch of capacitors here, and all of them are in parallel. Look here, there are two resistors here and two resistors here for discharging these capacitors for safety purposes. And there are three terminals here for connecting the capacitor bank, the main power circuit. There are four screws here to connect the capacitor bank on the top of the power PCB to fix it there. Look, all of these capacitors are in parallel. Look, the capacitor bank A+, capacitor bank A-, capacitor bank B plus and B minus. These signals are here and all of them are connected together. The positive side to positive side, negative side to negative side, and they are passed through these terminals to the main power circuit. I'm skipping this. Learning or understanding this part is not a big deal, you know. This is the second part, the power circuit. Look, there are 10 channels here. There are 10 channels. The first one, second one, third one, fourth one, fifth one, and so on. The others are here. These are the circuits for the power line. I'm skipping the 3D view and I'm gonna look at the schematics. Look, for each of the channels, we have a channel circuit here. This is one of them. This is the second one. This is the third one. And there are 10 identical circuits here for each of channels. Actually, the signal which is going to activate the channel is different. Here, light channel 0. Here is light channel 5, light channel 9, light channel 8, light channel 3, light channel 4, 2, and 1. We are going to consider one of them, not all of them. All of them are identical. This is the terminal for connecting the output of channel to the LED strips. It is not a big deal. Look, Here it is. It is this terminal, this blue terminal here. And we have a snubber circuit here and a flywheel diode here. The main part is this IGBT. Look, it is this one. This is the IGBT for switching the power voltage, actually about 300 volts. Look, this IGBT is gonna switch 300 volts or even more than 300 volts. Look, the positive side of the power supply is directly connected to the terminal, and the negative side is switched through this IGBT. So if we turn on this IGBT, the output will be activated and the output light will be turned on. And if we deactivate this or turn this off, the output will be off. Right? Here, when the light channel 1 or other signals, the same signals in the same circuits, is activated, for example, it is 5 volts, then this small C945 transistor will be turned on. And if this transistor is on, it will pull down the voltage at the gate of this IGBT to 0 volts. So this IGBT will be turned off and the channel will be turned off actually. And when the voltage at the signal is 0 volts, this transistor will be turned off and the voltage at the gate terminal of this IGBT will be pulled up to 9 volts and the IGBT will be turned on and the channel will be turned on. It is not very difficult to understand. If you pay a little more attention, you will find out how it is working. These screws here are used to fix the capacitor bank at the top of the circuit. We have corresponding screws on the capacitor bank actually. Here is the main power. The main power is coming through this 3-pin terminal. It is passing through this line filter and passing through this fuse, and it is reaching to this varistor for safety purposes. I've used the varistor for safety purposes, and after varistor we have the phase and neutral ready to use, and we have used it here. Look here in the main switch power. Look, there's a signal here, SIG triac starter. We can activate this signal. So we will actually activate this opto-triac, and this opto-triac will activate this main triac. It's very strong triac here. It's BTA16, which is able to conduct 16 amperes of current at the main power. It is very strong. And here is the snubber circuit. And the neutral is connected directly to the rectifier, but the phase will be switched through this triac. This triac will let the phase pass through itself and reach the rectifier. Here there are 2 NTCs here. These NTCs are power NTCs, which are used to reduce the inrush current. You know, when the capacitors are discharged or fully discharged, look, the output of this diode bridge is directly connected to the capacitors. If the capacitors are fully discharged and you accidentally or suddenly turn this triac on, the amount of current flowing through those capacitors will be very high. Will be very high. So I have used these NTCs here to reduce the inrush current at the beginning of the process. So the microcontroller will be able to turn the whole power circuit on or off using this signal here. The microcontroller is on the other circuit. We will consider that. I will explain that later in this video. Yeah, and there is no big thing here, it's not very important thing here. There are two shift registers which are used to provide signals for the 10 channels, which are derived by microcontroller. Microcontroller is able to put values on these signals using these three signals: seek show power, seek shift power, seek data power. If the microcontroller have access to these three signals, it will access to all of these 10 channel signals. I have explained the 74 HC595 IC in one of the previous episodes. You can watch that video to fully understand how these ICs work. These are very incredible ICs, very nice. They are my favorite. And by the way, there is a 9-volt adapter on the PCB. Look, the 9-volt external adapter is connected here. The input of the 9-volt adapter, which is the main power, is connected through these terminals, the adapter, and the output of the 9-volt adapter is connected through this terminal to the main circuit. Look, these terminals are here. Phase and neutral are connected to the 9-volt adapter through this terminal, and the output of 9-volt adapter is coming from this terminal, and it is passing through a 9-volt fuse. And actually I have used another diode here for safety purposes, and another capacitor here for some purposes. I'm not going to dive into very small details. We have a L7805 regulator, 5-volt regulator here. The output of the adapter, the 9-volt, is coming through the signal to the L7805, and the output of L7805 here is the 5 volts, which is connected to the 5-volt network here. There's no other detail here, and there is the terminal which is used to connect the power circuit, power PCB, to the control PCB here. I have passed the ground and 5 volts through these pins to the next PCB, and these signals are coming from the microcontroller from the next PCB. Look here, this is the next PCB. The microcontroller is at the bottom layer here. And this is schematics for the next PCB, the control PCB here. There's a microcontroller here which is powered up using the signals, and there are two 7 segments here which are powered up using these 2 shift registers. Actually, we have 4 shift registers in this project, 2 for 7 segments and 2 for light channels. These are capacitors for the shift registers here. There's a buzzer circuit here, and this is the same connector pin header, IDC 10x2 IDC box. This is reset button circuit here. This is AT24C32 IC circuit here. It is a EEPROM memory IC, which is explained in the previous episode. This is the IR sensor for receiving signals from remote controller, and this is the learn button circuit. There's a button in the project. When you press that button, the microcontroller will go to the learning process. Actually, at the beginning of the microcontroller program, you have to press this learn button and then press the reset button and release the reset button and hold the learn button. Then the microcontroller will enter the learn process, and then you can learn any remote controller, the system, and then the system will work with that remote controller. This is the regulator circuit here, actually a 3.3 volt regulator, AMS1117. These are capacitors, bypass capacitors, and there are three LEDs at the circuit. This is the circuit for crystal oscillator, external crystal, and these are two screws here for fixing the PCB on its place. You can use more than two or less than two. You can replace or move, or you can do any changes on these screws according to your requirements. These are two connectors. The first one is for the UART protocol, which I used for debugging purposes. You can remove this from the project now. And this is the connector for the programmer. And there's no other details here. These are the PCBs, the schematics, and this is the PCB. You can look at this PCB and do any changes to this circuit. Look, this is the infrared receiver circuit, receiver sensor. This is the sensor. It's enough for the PCB and schematics. I'm gonna enter. Oh, this is another project. I'm gonna close this project and open the infrared remote controller light system project. Look, this is the pinout for the STM32F030K6T6 microcontroller, and these are pins used at this project. There are some header files here which are defined by me. I have defined these. This is address map where some addresses are indicated here. The bit function is defined here. E2PRAM memory controller is here. These are two main functions for writing or reading the memory, and these are some other functions which are using the main functions. The next file is initialization file, which is used to set S and T on 7 segments, then turn off the light channel and send some messages to the user, and then start the timer, which is not a big deal here. IR remote.h here is used to read and validate the signals coming from the remote controller, and this is the function, callback function for external interrupt. The learn process is defined here on learn keys.h. There's a single function here. The next file is light channels.h. There are some functions here for setting values to light channels. Look, these functions are used to send bytes or bits to the light channels, and actually for turning on a single channel and turning off the single channel, or toggling the channels, and some other functions are here. Load settings.h is used to load some settings from EEPRAM memory, the buzzer status, power status, and update light power light state, update power state LED actually, and the current program. Some other loadings are here, some other settings are set here. The main.h is not important. It is created by the system. My variables here is used to define some variables and some constants and some defines here. Actually, I have defined these instead of these to simplify the main program. The next file is 7segment.h, which is very similar to light channels. There are some functions here for setting values and displaying correct characters on 7-segment displays. And it's it. There's no specific thing left. I think you can download all these files from the link in the description. And actually, there's no big deal in understanding this project. It is not very simple, but it is not very difficult actually. You can use these files and build this project for yourself and learn how to program STM32 microcontrollers. And there are very important and useful details in this project. You can learn about them actually, and that's it. This project is over, and this was the last episode. If you like these types of projects, let me know in the comment section below here. And if you like this project, or if you like this video, or if you liked one of the videos in this playlist, please like this video, give it a thumbs up, and subscribe to my channel to learn more about microcontrollers, electronics, and programming actually. Until the next video, take care of yourself and have a good one. See you in the next video.